In this video, I'm going to teach you everything you need to know about how airplanes maneuver in the skies. All objects have what's known as a center of gravity. This is an average location of where the weight of an object is concentrated. We can consider this the point where all of the weight of the object is concentrated. Because of this, any movement of that object will be around this point. We can see that concept in this image right here. Aircraft motion can be simplified into three different types of motion around the center of gravity: roll, pitch, and yaw. A roll is a movement that occurs around the axis that spans from the nose to the tail of the aircraft, that tilts the wings in one way or another. Pitch has to do with the angle of attack that I discussed more in depth in my 4 Forces of Flight video. Pitch is the nose moving up and down around the center of gravity, like this. A yaw movement is when the aircraft moves from side to side, just like a boat on water. In my video where I reacted to Star Wars spacecraft, I mentioned that spacecraft and aircraft don't move the same. Aircraft use what's known as control surfaces to push the aircraft in one direction or another. The utilization of control surfaces is how roll, pitch, and yaw movements are achieved. These parts of the aircraft push the air in one way or another and cause a moment on the aircraft to result in a roll, pitch, or a yaw movement. Control surfaces are divided into 2 categories: primary and secondary. Primary control surfaces include elevators, ailerons, and rudders. Engineer George Cayley was the first to utilize an elevator on his glider. His glider featured a horizontal tail that tilted up and down to deflect the air in a way that would cause a pitching moment on his glider. When he would tilt the elevator upward, this would push on the aircraft in a downward direction because it's behind the center of gravity and would result in a pitch upwards, like this. The opposite occurs when the tail is pointed downwards. This results in a pushing on the tail in the upwards direction and a pitch down. These elevators are normally placed towards the rear of the tail, but sometimes they encompass the entire tail, such as certain fighter jets, such as the F-18. This horizontal tail portion is called a horizontal stabilizer and is used in almost every conventional aircraft. The control surfaces that control the rolling of the aircraft are known as ailerons. Ailerons are placed near the outer edges of the wings of each side. They move like this. As the left aileron is deflected upward, the right aileron is deflected downward. As we have learned, increasing the angle of attack on an aircraft will increase its lift. When we deflect the aileron down, it increases the lift on that side. But when we increase the aileron up, it decreases the lift on the opposite side. This results in a rolling motion of the wings. The ailerons always work opposite each other. Right aileron goes up, left aileron goes down, and vice versa. The final primary control surface is known as the rudder. This is found in the vertical stabilizer, or the vertical portion of the tail in the rear. When the rudder is deflected to the left, this will push on the aircraft on the tail in this direction and will make the aircraft turn left. All 3 of these primary control surfaces control the roll, pitch, and yaw of the aircraft. These primary control surfaces allow the pilot to do what's called trimming. This will keep one of the control surfaces deflected in order to continue to have steady level flight. For instance, if a pilot wanted to maintain the same altitude, he could deflect the elevator slightly to keep the lift force equal to the weight force. This would maintain the aircraft at that same altitude. The pilot can do this with other control surfaces also to offset other imbalances in flight, such as crosswinds. The other category of control surfaces is known as secondary control surfaces. These secondary control surfaces have other functions in flight beyond controlling roll, pitch, and yaw. The secondary control surfaces I'm going to explain to you are flaps, slats, and air brakes. Flaps are placed towards the rear of the wing inside of the ailerons on either side. The flaps extend from the rear surface of the wing and deflect downwards. This increases the curvature of the top surface of the wing, thus increasing the generation of lift. Not only does it increase the curvature of the top portion of the wing, but it also increases the surface area of the wing in order to generate even more lift. The next time you take a flight, you'll notice that the flaps extend outward and downward during takeoff and landing. However, these flaps are rarely used during other portions of flight because they cause so much drag. Another control surface that is meant to increase the lift generation of an aircraft are known as slats, or leading edge flaps, because they're on the front of the wing. These slats extend out of the wing and downward. The last secondary surface I'm going to explain are known as air brakes or spoilers. You may recall Maverick saying,
"I'm gonna hit the brakes, he'll fly right by."
Do airplanes have brakes? Well, kind of. They have air brakes or spoilers. Spoilers are found sometimes on the surface of the wing and sometimes in the middle of the fuselage. Air brakes are meant to disrupt large amounts of air in order to slow the aircraft in a dramatic fashion. Commercial flights will usually only use this when they need to slow down very quickly. There are some other types of control surfaces that I haven't mentioned here that I may mention in a future video. These include flaperons, elevons, and canards. But these are usually only found in uncommon aircraft geometries. So if you learned something in this video, please give it a like. If you enjoyed this content and you want to see more of it, go ahead and hit that subscribe button. Thank you so much for watching, and Godspeed.